Okay, we are doing reduction formulae for 90 minus theta, 90 plus theta, and theta minus 90. And just like with the other reductions we've done, we're going to come up with a nice way of remembering how to do it. Okay, for the first one, we're not going to use our cast diagram. You might think, oh, well, the first thing we're going to do is draw this. We're not actually, because there's an easier way to look at this. And that is, think of just a freestanding triangle. So please draw a freestanding right angle triangle. Let's say that this angle we're 20 degrees. This is certainly not to scale. And let's call this side A, B, and C. So have you got your triangle down? Now I'll ask you some questions about this. And you say, well, what is sine of 20 degrees? Okay, easy enough, right? Opposite over hypotenuse. So this one is just B over C. Now I'll ask you another question. I say, what is cos of 70 degrees? Hopefully you said, well, cos of 70, there's no 70 in the diagram, but hey, wait a second. If that's 20 and that's 90, all the angles need to add up to 180, so this one here must be 70 degrees, because 20 and 70 make 90. So therefore, cos of 70, well, there's 70, adjacent over hypotenuse, B over C. Cool. So, wait. Do you notice anything about sine 20 and cos 70? They're completely the same. So let's see, does this always going to work? So let's draw another triangle. And for this one, right angle triangle, let's call this angle theta, A, B, C. So click on when you've drawn your triangle. Okay, this time we're going to say, what is sine of theta? Okay, sine of theta, opposite over hypotenuse. This looks pretty much the same, right? And now we're going to go, what is cos of 90 minus theta? So it feels like it should be the same because they're carrying on the same logic. But why is this side 90 minus theta? Well, let's just convince ourselves here that if that's theta, then theta plus this mystery angle, theta plus our mystery angle should be 90, because then 90 plus this 90 gives us our 180. So from our equation on the bottom right here, if we could just subtract theta from each side, so if we subtracted theta from one side and from the other, then our mystery angle is just 90 minus theta. So that's 90 minus theta. Maybe you're comfortable with that already, but there's our full explanation. So therefore, cos of 90 minus theta is, well, adjacent over hypotenuse. This is equal to B over C. And the same for the other way around. So let's say, what is cos of theta? Well, cos is adjacent over hypotenuse, so this is A over C. And what is sine of 90 minus theta? Well, that's sine of this angle, adjacent over hypotenuse. So, no, sorry, sine, opposite over hypotenuse, A over C. So what this reduction tells us is that if you're given sine of 90 minus theta, then it's just the same as cos of theta. And if you're given cos of 90 minus theta, this is just the same as sine of theta. And this one, just be ready to know it in when it's got a theta, like these ones. Or if you see sine 20, be ready to change sine of 20 to cos of 70. So with an actual angle in there, and just think about a freestanding triangle. That's our first reduction. Let's run through the other two, and I want to keep this in the same video so we keep going in the same line of logic. 90 plus theta. For this one, we are going to need a Cartesian plane. So please have a Cartesian plane ready and a second one, because we're going to explain why this works in the first one, and then we're going to use a nice little trick to remember our reduction. So for the first one, we're going to explain why it works in a bit more detail. And then the second one, it's just going to be our cast diagram that we love so much, and we're going to use that to explain it a bit quicker. And the second one's the one we're going to use. Okay, so let's start with a point. Somewhere in the first quadrant, drawn it a bit longer this way purposely, and we've got this point A, B, like we had before, with the distance r away from the origin. Remember, r is the hypotenuse really for our right angle triangle. So if it's AB, what's this bottom side length here? Well, it's going to be A. And what's this side length over here? It's going to be B. So there's our right angle triangle with theta, the angle that it makes from the positive x-axis. Now in this one, just to remind ourselves what we're working with here, we're trying to see what's happening with 90 plus theta. So all three reductions we're doing together now are about 90. 90 minus theta, 90 plus theta, theta minus 90. And so we're going to add 90 degrees. So if we added 90, I'm going to draw it here. I'm not going to ask you to draw it first. We're going to have a triangle sitting up there where that's 90, and we've added another 90 degrees here. Okay, now let's look at our two triangles. They're congruent. They're the same. So I'm going to hit a note here just to make sure you pause to see how this triangle has reflected up to make that triangle there. So I don't know if I've got my reflection right. I think I have. So that triangle, if that's the bottom right and the right angle here, it's kind of just, it's reflected up that way. Okay. It's quite difficult to do in reverse. So there's our triangle. Maybe it's like that and it's reflected down, something like that. Okay. But let's see what I'm talking about here. If this long side was A, then this long side here would be A. So if this is a point on the Cartesian plane, this point, and the long side is A, what's the y value? Yeah, it's A, because it's that same length there. So if that were 4, then this would be 4. So it would be 4. Notice how it's just the same as the x value. If this short side was B, therefore this short side is B, therefore what's the x value of this point? Okay, now hopefully some of you said minus B, or if you said positive B, you can see why it's actually negative B. It's in the negative direction. If this were 3, then this would be negative 3. Okay, so we've got all we need except to go, well, if that were theta, this angle here would be theta as well, but we don't really need that. What we really are interested in is this angle from the positive x-axis up to this line. Well, if that little bit's theta and this big bit is 90, then that's 90 plus theta, which is what we're interested in, remember? So now we can start looking at a few of our ratios. Remember, this is the explanation of why it works. Then we're going to get into just a way to remember it. Okay, so in this original triangle, let's look at what sine theta and cos theta are. So sine theta, what is sine theta for this triangle? Well, sine is y over r, so it's just b over r, or if you looked at the triangle, you'd go opposite over hypotenuse. Okay, for cos theta, what is cos theta? Well, cos is x over r, so it's a over r, or if you looked at it, the little triangle adjacent over hypotenuse. Now let's look at this triangle up top here. I'm going to add one thing that may seem strange, and I'm going to call this negative b, even though the side length is b, just to make sure we know that we're dealing with negative b as the x value. Okay, and let's look at sine theta and of cos theta. Okay, sine theta. What is sine? Not theta. Sorry, that's a mistake. We're looking at 90 plus theta. That's how we got into that triangle up there. So we're saying, what is sine of 90 plus theta? Or of course it could have been theta plus 90. And we're looking at cos of 90 plus theta. Okay, so sine of 90 plus theta. What do you think it is? Okay, sine is, we said it was y over r. R has stayed the same, but our y value of this point is now a. So this is a over r. So sine of theta is y over r, so a over r. Now, do you notice something about this and this? Sine 90 plus theta is just the same as cos theta. Okay, that's going to be our first rule. Sine theta, sine of 90 plus theta is equal to cos theta. That's our first reduction from this. Now the second one we're going to see is, what is cos of 90 degrees plus theta? Okay, well, let's work out what cos theta is. Cos of 90 plus theta, at least. Cos 90 plus theta, well, cos is x over r. So what is it in this case? Well, our x value is negative b, so this is negative b over r. So therefore, it looks very similar to this one up here, except it's just negative. So cos of 90 plus theta is exactly the same as sine of theta. Only difference is that it's negative. So there are two reduction formulae for 90 plus and minus, for 90 plus theta. And catch our breath for a second to see, that's the explanation, that's all well and good, but how are we going to remember this? Because we've got quite a few things we're just remembering already. Let's look at our cast diagram. So pause to make sure you've got this cast diagram down, and we're just going to fill in the blanks on the right hand side. So rewrite this if you've got it written down, just for sine 90 plus theta, cos 90 plus theta. Okay, so sine 90 plus theta. Where are we working? Well, if theta's over here and we're adding 90, we must be moving into this quadrant. That's because here's 90, so 90 plus theta must be in this quadrant. Just like 180 plus theta is over here, 360 minus is here. We're in the second quadrant. We are going to remember that whenever we're dealing with a 90, sine's going to change to cos, and cos is going to change to sine. So sine is going to change to cos theta, and cos theta is going to change to sine of theta. So let's focus on the first one. Sine changes to cos, and we just need to work out, is it positive or negative? Well, let's look at our original trig ratio. Is sine positive or negative in the second quadrant? It's positive, so therefore stays positive. Cos changes to sine when it's 90 degrees. Is cos positive or negative in the second quadrant? It's negative, so it changes to negative. So here's what we're going to use all the time. In this case, if we were to look at these two, our first one's in the Cartesian plane, well, 90 minus theta is still in the first quadrant, because there's 90, and we're subtracting theta, and all trig ratios are positive, so positive stayed positive, positive stayed positive. So far, sine changes to cos, cos changes to sine. Here, everything's positive, so it stays positive. Here, we just had to go, well, sine is positive, so it stays positive. Cos is negative, so it becomes negative sine. Okay, now last one. And remember, we kind of slowly get the hang of this. So hopefully you've been building your confidence this week with these seeming tremendously difficult to start with. Okay, for our last one, we're not going through a full explanation of it. We're going to just do the quick way of looking at it, but shout if you want a long, proper explanation of it. We're just going to use our cast diagram, and we're going to say theta minus 90 degrees. Now, theta minus 90 degrees, let's have our 2 ready to go, well, we're interested in sine theta minus 90 and let's give ourselves a bit of space, and cos of theta minus 90. Don't worry about tan, we're not doing these reductions for tan. So sine of theta minus 90 is going to equal something, and cos of theta minus 90 equals something. Now sine is going to change to cos, and cos is going to change to sine. Reason being the 90. Well, not the reason, but that's how we're going to remember it. We see a 90, sine changes to cos, cos changes to sine. And we're just going to use our cast diagram. Which quadrant are we working in if we're dealing with theta minus 90 degrees? It's like I'm giving it away, aren't I? We're dealing down here. So we're in this quadrant because we're going, if theta were up here in the first quadrant, and we've gone clockwise, we've subtracted 90, we're down here. So looking at our original trig function, we're in the fourth quadrant. Is sine positive or negative in the fourth quadrant? It's negative, so this must be negative. Is cos positive or negative in the fourth quadrant? Positive, so therefore this stays positive. So cos of theta minus 90 is just sine theta. So those are our 3 reductions. I'm going to just end this by putting them all together. And let's put them here. So we've got, first of all, sine of, what is our first one? Let's have it from the video here. We said 90 minus theta. How are we going to remember all of these? Sine of 90 minus theta and cos of 90 minus theta. And they're going to become something. And then we said, what about 90 plus theta? So we said, well, we've got sine of 90 plus theta and cos of 90 plus theta. And lastly, we said, well, we could also look at theta minus 90 or cos of theta minus 90. And let's have our cast diagram here so we can do them all easily. Let's do a mini cast diagram for each of them. Cast, cast, cast. C-A-S-T, C-A-S-T, C-A-S-T. Pause, have we got that down? Okay, so this is the essence of everything we've just done in the video in one go. In each case, we've gone, there's a 90. So if there's a 90, sine changes to cos, cos changes to sine. So it's going to be theta, theta. Sine changes to cos, cos changes to sine. Sine changes to cos, cos changes to sine. And now all we have to look at in each case is positive or negative. 90 minus theta. Here's 90. If we've subtracted theta, which quadrant are we working in? First quadrant, everything's positive, so these stay positive. Easy. 90 plus theta. Which quadrant are we working in? Well, here's 90. We've added theta. We're in the second quadrant. Is sine positive or negative? Positive. Is cos positive or negative? Negative. Okay, sine of theta minus 90. Which quadrant are we working in when we're going theta minus 90? Well, here's theta in this quadrant, and we've subtracted 90, so we've gone down into this quadrant. Is sine positive or negative in the fourth quadrant? It's negative. Is cos positive or negative in the fourth quadrant? It's positive. Done. So there it was. And the last bit, after all that explanation, I think that explains it all okay. So, that's that.